Right. So today we are going to do the 10th property then. Decay rate. Now, decay rate is basically defined as, we say that as the X-rays propagate, the intensity decreases, okay, with the distance traveled within the medium according to, now please remember this equation, I equals to I naught E minus mu x. So this is the equation, okay. Now in this equation, this I is basically intensity of, okay, let's make it short. Intensity at distance x, all right. This is the initial incident intensity, and that you see is basically the linear absorption coefficient. The SI units for this are meter minus 1. Some times the examiner also calls it linear attenuation coefficient. Basically it's the same thing, just a different name. And then this x you see is the linear distance traveled within the medium, like that. So what I mean by this is, let me try to make a bone that I don't know how it looks like. Okay, like that. Suppose this is a bone, and we're looking at the bone from this axis, okay, like that. So what we're saying is that at this point, this is the X-ray, so at this point we're saying this is I naught, where it starts to enter the bone. And then of course when it has traveled a displacement or distance in a straight line, so we're looking at the intensity I at that point, which means it has traveled a distance like this in a straight line, all right, it should be linear. And the X-ray is basically going from here till here. Is that clear, everybody? Now, so how it changes, because it's an exponential function, as you can see. So when you draw a graph of this, you might realize, okay, this is the intensity in watts per meter square, and this is the distance in meters. So the starting intensity was I naught, and it means that it will show you an exponential curve, and basically when exactly it's gonna get 1 2 3 4 5 6 7 1 2 3 4, so somewhere here, oh my god, exactly at the center. So when the intensity is going to be halved, it means that it has basically caused it to move to a value which is x half. Now x half does not mean that it's basically the distance is being halved, it's a subscript. Okay, so this x half basically has a meaning, and it is called, so this is the 11th section, I believe, yes, and it is called the half value thickness of a material. So half value thickness of a material is basically this x half, and basically what it means is it's a linear length of a material required for incident X-rays, initial intensity to reduce to half of its original value. So this is exactly like half-life is half value thickness. Remember that this is a scalar quantity. The SI units of obviously thickness would be this length, meters, and the symbol that we use is x and half in the subscript. So we're not halving the value, it's just the whole thing. Is that clear, everybody? If you have any questions, please let me know. Abdul Moiz, Aman, Nadia, Saman, Gatika. Any questions, please let me know. Okay. Now, so suppose they give you a question where they say express half value thickness in terms of mu. Okay, that's how we generally do it. So we say at half value thickness, intensity becomes half of its original value, right? So intensity is given by I naught E minus mu x. So that's the formula. We can replace this as I naught over 2 equals to I naught, and at that point we're going to get half value thickness right here. And then basically I naught and I naught cancel out. We are left with half equals to E minus mu x half, and then you can take ln on both sides. So if you take ln, this will be minus mu x half multiplied by ln of E. This can be written as minus ln of 2. ln E you guys know already, it's just 1. So that means that half value thickness equals to ln 2 over mu, and that's how you can find the value. And basically it's the same as, you remember 0.693 over mu. That's the same, almost the same formula as half-life, because it's the same thing with a different value. That's why. All right, is that clear, everybody? Any questions, please let me know. All right. Now, just look at it, copy this, and let me know if something's there that I can help you explaining with. However, I'm gonna show you a question. I'm gonna do that. Just a second.
Sir, how can we define linear absorption coefficient?
Well, there's no definition really. It's just value of how much.
Sir, I saw one question where they asked to define for 3 marks.
Really? Why haven't I seen that question?
Sir, it's in the worksheet you gave. Quantum.
Linear absorption coefficient defined. Okay. Well, it's not that hard, but then why would they ask you that? Linear absorption coefficient is basically how much X-rays are basically absorbed, right? Per unit length. It should be like that though. But for 3 marks, I have to look at it again. Why there is a question like that? In the worksheet I gave. When did I give you the worksheet? For the quantum one?
Yeah, in that there was a question for this.
Okay, I'm gonna see it and then I'm gonna get back to you. I haven't seen that question. For 3 marks, I don't know. For 1 mark, I could do that. Okay. Anyway, so now we're gonna go there. Don't worry about that. At the end of the class, let's look at it. What's the question all about? There must be something else with it. There must be something, but no worries. Anyway, so right now what we're looking at is basically a classic question. These questions will come like again and again. So it says a student investigates absorption of X-rays across section of the model arm. So as you can see, there is flesh and there is bone, and then they've made 2 sections, line BB and line MM. The bone has a linear like thickness of 4 centimeter, and the flesh has a thickness of 8 centimeter where there's no bone, right? So okay, crazy. All right, now with respect to that, first of all, they've asked you the linear absorption coefficient of muscle and bone are this and this respectively. They have given you this, and they say calculate the ratio of intensity of emergent ray, intensity of incident X-ray. All right, so that's what we're gonna do now. So right now they've said only mm. Okay, so there's only one thing. Okay, so the only formula that we have is basically I equals to I naught E minus mu x, like that. Okay, what we need is we need the intensity over the incident intensity, so we just need mu x, like that. So the absorption of muscle is 0.20, which means that we can write this as 0.20, and this is in centimeters, so let's keep it there because the length of line mm is also in centimeters, which is 8, so we don't need to change that. And then we're going to get a ratio of 0.20. Is that clear, everyone? Nadia and Suman and Aman and Gatika. Any issues? Okay.
So what is MM and BB?
This is just the section. where the rays are going through. Okay.
Okay.
All right. Now, then it says BB. Now the issue with BB is that they're like the whole thing passes through the first section here when it's incident like this, and then it goes to the second section, which is a bone, and then it goes to the muscle again, and then it goes out. Do you guys understand? What we need is, if this is I naught and this is I, he's asking for the ratio at the end. Okay. Now the issues with these questions are that they can be terribly wrong, but I'm going to show you one of the easiest methods that you can do. Okay. So what you're going to do is you're going to basically simply look at the ends here. You're going to say, okay, this is I and I naught. You're going to write I over I naught, and then what you're going to do is you're going to multiply each coefficient, like exponential value of each section. Like for example, the first one, which is basically, I'm going to write the muscle in the first section, that is E minus muscle 0.20. And now if you look at it, this distance is basically, if this is 4, it means this distance is 2 centimeter, and this distance is 4, and this distance is 2 centimeter. That's make up the whole 8, right? So it means this has to be 2, and then you multiply this with because this is a ratio, right? So you multiply by minus. Now bone is like, coefficient is 12, it's given right here, and then the distance is 4, so I'm going to multiply 4 here, and then you multiply E, and then you say minus, and then 0.20 is the coefficient again. It only goes to 2, so I'm going to multiply 2. And when you solve all this, you, like, this is muscle in the first section, then this is the bone in the second section, and this is the muscle again in the third section, and it comes out from there. So this should give you somewhat like 6.4 times 10 raised to minus 22. Is that clear? So you're only dealing with every section separately, right? And multiplying its exponential function only. So that way you are going to get it like in like just 2 seconds. Understood? Now, if you want, I can do step by step as well. It will take some time, but I don't think you will even understand that. But you want me to do the stepwise, or is it fine? Yes, please. It's okay?
This is fine.
Okay, cool. So just remember this will help you get all the answers, right? So this is how these are solved. Anyway, then in the next part it says state whether your answer in part A indicate the X-ray image is sharp. Now, sharpness is related to how well defined the boundaries are, right? So the thing is that by absorption we cannot really tell about the boundaries. So what we're going to write here, we say that sharpness cannot be determined by the answers. Okay. And for a good contrast, if you see when mm was only flesh and there was a bone, now when there was a bone, look at the difference between two answers. It's huge. It means that bone is absorbing a lot of X-rays. So if there is a large difference between absorptions or fractions, then we say yes, because a major absorption, let's say major absorption occurred in the bone area. So there is a lot of difference, that's why. Is that clear, everybody? All right. So now, just give me a second, please. If you check the notes I posted, in those notes you will find these things, okay? The detailed, working for the previous part. But that's up to you. If you want to do it, it's not necessary. It's a very, very long one. Anyway, so going on the last thing from this topic, I mean X-rays, we're going to look at the CT scan. Uh-oh. Now, a CT scan is basically called computer tomography. And there are two things of interest: voxel and pixel. So there is a difference between them. So voxel is basically the volumetric 3D element, and pixel is a picture element. And it is the smallest bit addressable on screen. Alright, so this is how the information is given out or stored. Now, you write this down, please. I'm going to show you something then. Just give me 1 minute. And then we copy the diagram and then we're going to go forward. Okay, about in 10 minutes time, you guys need to rejoin, okay? Okay, now, so basically it looks like the volumetric 3D element is the voxel, and each, each certain side is a pixel, right? As you can see, and we can view it from different angles. Usually it's done with 45 degrees. Okay, now with respect to that, then let's write about it a bit before we want to go in detail. So when the picture is taken, what we do is we say that a slice means that we're cutting from a certain angle, all right, is chosen at random and broken into a voxel. Then X-rays are passed through it. Then what you do is that every section at of body has a different absorption and intensity value that we've just done above before that. So okay, let's write this number on each voxel is the pixel intensity that needs to be reproduced. I'm going to show you how it is reproduced, and then the total pixel reading is called background reading. Now let me just show you a bit about it. Okay. Now you can write down, then we're going to go down. Now CT scan is the most, like, the easiest topic of all A levels, because it requires basically nothing at all. So I'll show you how to solve these questions, and you'll be very, very happy actually. Now, suppose we have these readings initially from the horizontal axis. So what computer reads it? Computer says, okay, 3 plus 4, 7, and 8 plus 5 is 13. So on this side, right? So we're looking at horizontal. And then it creates another address, like it puts like these readings on pixels, like 7, 7 on horizontally, and 13 and 13. Do you guys understand? All right, now the next thing it does is that now here the new address this is not required, but anyway, this is what is stored, and now from this side at 45 angles it does the same for the same kind of body. So from a different angle, now it gives a different reading. Let me show you how. So here it will be like, on this one you will get 4, and then 3 plus 5, 8, because 3 and 5 are like in a line, and then 8 on this side as well. And then it will add this with the previous reading that it had saved, 7, 7, 13 and 13. into a new one. So now look at this. In this direction, 4 is added with 7, which means that it's going to be 4 plus 7, 11 on this side. 8 plus 7 will be 15 on this side. 8 plus 13, it will be 21. And 8 plus 13, 21 here. Do you guys understand this? Any questions? Please let me know. Now, the next orientation, like in the third orientation, in the second orientation, it basically does this. So you have now 15, 11, 21 and 21 stored, and from the vertical axis it's doing now. So you're gonna get 4 plus 5 as 9, and 3 plus 8 as 11 now from the vertical. And the previous reading that we had was 15, 11, 21 and 21. And now 9 will be added to 11. So on the top right, it's going to be 9 plus 11 is 20. And 9 plus 21 is 30. Whereas now 11 plus 15 is 26, I believe. And 11 plus 21 is 32. Any questions? Abdul Moiz, you're getting it right. Aman, Gatika, Nadia and Suman.
Yes, sir.
Yes, sir.
Okay, very good. And then now this is the reading that we have, 26, 20, 32. Computer has stored it, and now we take it from the other side, right? Turning it every 45 degrees 3 times. So because we are doing like 3D modeling here. Now you're gonna get 5 on this side, and 4 plus 8 because they're in line is 12, and then 3. Okay, and now basically the previous reading that we had was 26, 20, 32, 30. 26, 20, 32, 30. This was the reading. Now we're gonna add it. So 3 gets added with 26. It becomes 29 on the far top left. And then 12 is added to 20. That becomes 32. And 12 is added to 32. That becomes 44. And then 5 is added to 30. That becomes 35. Like that. So after like 3 different orientations, now we are done with the whole system. As you can see, the 3 orientations right now. So it's like 1, 2 and 3 sides, all right, like that. So do remember that. Okay, now the most important thing is that when you're looking at this, you should remember that the background reading is taken like if you go to the first one, this was the original pixel reading. You just need to add them together, like 3 plus 4 plus 8 plus 5. So you're gonna say 3 plus 4 plus 8 You guys can see the screen?
Yes, sir.
All right. So now what you're going to do is you're going to see that background reading is the first one. Like you just add 3 plus 4 plus 8 plus 5. And what you see is you're going to get like 20. Okay. Now, to go back from the final reading to some reading, what you do is you take the cell, you subtract the background reading, and then you divide by 3. So, for example, if I'm doing it 29, so 29 minus 20 is 9, divided by 3 is 3, right? And then 32 minus 12 minus 20 is 12, 12 divided by 3 is 4. And then here 44 minus 20 is 24, divided by 3 is 8. And then 35 minus 20 is 15, 15 divided by 3 is 5. So you might see that you're getting the same value that the original pixel was, right? Pixel values were. And then if you want to go back, like if they've given you something like this, you can find the background reading. Like for example, now the background reading will be 1 plus 4 plus 3 plus 7. So that will be 15. And now to go forward, what you do is you multiply the cell with 3. So 1 times 3 is 3 plus 15 is 18. And then 4 times 3 is 12, and 12 plus 15 is 27. 3 times 3 is 9, 9 plus 15 is 24. And 7 times 3 is 21. And 21 plus 15 is 36. Is that clear? So this is how you can go back and forth. Now if I say the background reading is like this, can you find the first one? Please quickly do it.
Sir, can you explain the first table again, please?
So you just need to subtract the background reading from the cell that you have. Like for the first one, you're doing 29 minus 20. That comes out to be 9. And then you divide by 3. Okay? That's going to be 3.
And how do we get the background reading?
By initially we had this from the previous question. Okay?
Okay.
Now the same thing I want you to do it for 25. Okay, the values are given. Can you please do it? All right. Okay, answers please. This is so simple. Why
So
not?
is it 10, 8, 2 and 5?
10, 8, 2 and 5. Yes, that's correct. Very good. 10, 8, 2 and 5. Now you already know this, so you can solve any questions from CT scan. Now the last thing we're going to do in 3 minutes is when he's going to ask you this question, and this question will come every single time, and he's going to say, briefly explain, sometimes you're going to state the principles of CT scan. So you need to rote learn this, unfortunately, but that's how the world is now. 6-mark question, 6 points. The first point is that X-ray taken of a slice. Slice means, you know, like 45 or 90 or whatever, 0 degrees. And then repeated at different angles. Number 3, data is then processed. Number 4, then it is combined to form an image. Number 5, repeated for successive slices. Number 3, to create a 3D image that can be viewed from different angles. And that is my people 6 mark for this. All right, so you will have ample space. But yeah, that's how it goes, right? So if you have any questions now, please let me know. And that would be basically probably it for today. You can write it down, and that's the end of it. Yes. Okay. All right, that's pretty good now, and I hope to see you people next time. Have a
So
nice
are
day.
we done with the syllabus?
No, we're done with. We have 2 more things from this and astrophysics. 3 chapters left, basically.
Or no?
2 from medical physics and 1 from basically 1 more chapter after medical physics. We're like very close.
Okay. And so one more thing, what's the difference between voxel and pixel?
Voxel is the 3D element. What you see right now is a pixel, right? There are like 4 pixels there, as you can see, right? Voxel means this square, you see, 3D element.
That's it?
Yeah. All right. See you people then. Have a nice day. Bye.
So I'm sending you that question on Skype.
Sending that question on Skype.
The one with the linear coefficient. Yeah.
Yeah,
Sent.
I will see it and let you know. All right, bye. Have a nice day.
Bye.